Using a used indoor transformer in an outdoor application presents several concerns. Firstly, used indoor transformers are generally not designed for outdoor use. They often lack the necessary corrosion protection, weatherproofing, and appropriate cooling systems needed to withstand the elements. Exposing such a transformer to extreme temperatures, humidity, and precipitation can significantly reduce its lifespan. Secondly, starting a large 2000 horsepower motor creates substantial shock loading on the transformer. This is because the motor draws a high inrush current during startup. A used transformer, especially one that is 20 to 25 years old, may not be able to handle these repeated shock loads without experiencing damage or premature failure. Thirdly, using the primary breaker as a motor starter is generally not a recommended practice. Motor starters are specifically designed to handle the high inrush currents associated with starting motors. They provide features like reduced voltage starting to mitigate the impact of the inrush current. Circuit breakers, on the other hand, are primarily designed for overcurrent protection and may not be suitable for repeated motor starting duties. Using a primary breaker as a motor starter could lead to nuisance tripping or damage to the transformer over time. In terms of motor protection, dipping the motor in varnish is also questionable. While dipping provides some level of protection against environmental factors, it can also impair the motor's ability to dissipate heat effectively. Proper heat dissipation is critical for the motor's operation. If the varnish restricts heat transfer from the windings, the motor's insulation could overheat, which will potentially lead to premature failure. It's recommended to use a suitable outdoor transformer instead. Installing a new or refurbished transformer that is specifically designed and rated for outdoor applications is advisable. This will ensure that the transformer can withstand the environmental conditions and provide reliable operation. You should use an appropriate motor starter for the motor. Using a dedicated motor starter is important to start and stop the motor instead of relying on the primary breaker. Motor starters provide the necessary features for controlled motor starting and protection. Also, avoid varnish dipping on the motor. Explore alternative motor protection methods that do not restrict heat dissipation. There are other methods of protecting the motor windings that do not have the drawback of inhibiting heat transfer. Some examples of alternative motor protection methods include using modern insulation materials with improved thermal conductivity, employing proper motor ventilation and cooling systems, and implementing protective relays that monitor motor temperature and other critical parameters. These alternatives can provide adequate protection without compromising the motor's ability to dissipate heat. The proposed application raises significant concerns regarding the safety and reliability of the electrical system. The combination of factors, including using an old-use transformer outdoors with shock loading, questionable practice of using the primary breaker as a motor starter, and the potential for impaired motor heat dissipation could lead to significant failures and safety hazards. It's highly recommended to reconsider the proposal and implement a more appropriate electrical system design. Consider performing a comprehensive load study to determine the actual load requirements and select appropriately sized equipment. Ensure that all equipment is properly rated for the intended application and environmental conditions. Implement proper protection and control schemes to prevent overloads, short circuits, and other electrical faults. Conduct regular maintenance and inspections to identify and address any potential problems before they escalate. Consider consulting with a qualified electrical engineer to ensure that the electrical system design meets all applicable codes and standards and provides safe and reliable operation. Some key considerations for selecting an outdoor transformer include the appropriate kilovolt amp rating to meet the load requirements, the insulation class to withstand the operating voltage, the impedance to limit fault currents, the cooling method to dissipate heat effectively, the enclosure type to protect against environmental factors, and compliance with relevant industry standards such as Institute of Electrical and Electronics Engineers Standard C57.12 for liquid-filled transformers or Institute of Electrical and Electronics Engineers Standard C57.1291 for dry-type transformers. For motor starters, consider factors such as the voltage and current rating to match the motor requirements, the type of starting method such as across the line, reduced voltage, or solid state to minimize inrush current, the overload protection to prevent motor overheating, the short circuit protection to interrupt fault currents, the control features such as start-stop push buttons and remote control capabilities, and compliance with relevant industry standards such as National Electrical Manufacturers Association standards. When considering alternative motor protection methods, evaluate the effectiveness of each method in protecting against specific failure modes such as overloads, short circuits, ground faults, and insulation breakdown. Consider the impact of each method on motor performance, efficiency, and lifespan. Ensure that the chosen protection methods are compatible with the motor's operating characteristics and environmental conditions. When installing electrical equipment outdoors, ensure that it is properly grounded to provide a safe path for fault currents. Use corrosion-resistant materials and coatings to protect against rust and corrosion. Provide adequate drainage to prevent water accumulation. Install lightning protection to protect against voltage surges. Consider the potential for vandalism and theft and implement appropriate security measures. Proper coordination between the transformer, motor starter, and protective devices is crucial to ensure the safety and reliability of the electrical system. A coordination study should be conducted to determine the appropriate settings for overcurrent relays, fuses, and circuit breakers. The goal of the coordination study is to ensure that protective devices operate selectively to isolate faults without disrupting the entire system. The coordination study should consider the transformer's thermal withstand capability, the motor's starting characteristics, and the characteristics of the connected loads. The results of the coordination study should be documented and used to set the protective devices accordingly. Regular testing and maintenance of electrical equipment are essential to ensure its continued safe and reliable operation. Transformers should be inspected regularly for signs of damage such as oil leaks, corrosion, and overheating. Insulation resistance tests should be performed periodically to assess the condition of the transformer's insulation. Motor starters should be inspected for worn contacts, loose connections, and proper operation of protective devices. Motors should be inspected for bearing wear, insulation damage, and proper ventilation. Protective devices should be tested regularly to verify their proper operation. The frequency of testing and maintenance should be based on the equipment's operating conditions and manufacturer's recommendation. Detailed records of testing and maintenance activity should be maintained to track the equipment's performance over time. If the existing cooling fans are to be reused, ensure that they are properly rated for outdoor use and that they provide adequate airflow to dissipate heat from the transformer. Fans should be inspected regularly for proper operation and maintained as necessary. Consider using a redundant fan system to ensure continued cooling in the event of a fan failure. The enclosure that is used to house the transformer should be designed to protect against environmental factors such as rain, snow, wind, and sunlight. The enclosure should be constructed of durable materials that are resistant to corrosion. The enclosure should have adequate ventilation to prevent overheating. The enclosure should be properly grounded to provide a safe path for fault currents. The enclosure should be designed to prevent unauthorized access. The location of the transformer should be carefully considered to minimize the risk of damage from external factors such as floods, fire, and vehicle impact. The transformer should be located away from areas where flammable materials are stored. The transformer should be protected from vehicle traffic by barriers or other means. The transformer should be located in an area that is accessible for maintenance and repair. Before installing the used transformer, it should be thoroughly inspected and tested to ensure that it is in good working condition. The transformer should be cleaned and any necessary repairs should be made. The transformer's insulation should be tested to verify its integrity. The transformer's turns ratio and polarity should be checked. The transformer's impedance should be measured. The results of the inspection and testing should be documented. If the used 2000 horsepower motor has been rewound, it is important to verify that the rewinding was performed by a qualified shop using appropriate materials and techniques. The motor's insulation should be tested to verify its integrity. The motor's balance should be checked. The motor's bearing should be inspected. The motor's performance should be tested to verify that it meets the required specifications. The result of the inspection and testing should be documented. When selecting a replacement transformer, consider using a transformer with a higher efficiency rating to reduce energy consumption and operating costs. High-efficiency transformers use improved core materials and construction techniques to minimize losses. The use of a high-efficiency transformer can result in significant savings over the transformer's lifespan. When selecting a motor starter, consider using a solid-state starter to reduce inrush current and provide smooth acceleration. Solid-state starters use electronic components to control the voltage applied to the motor during startup. This reduces the stress on the motor and the connected equipment. Solid-state starters can also provide improved motor protection and control features. In summary, the proposed application of using a used indoor transformer outdoors to start a large motor raises significant concerns regarding safety, reliability, and performance. It is highly recommended to carefully evaluate the potential risks and consider alternative solutions that are better suited for the intended application.